of university in UK. And this presentation, practical methods for compatibility evaluation of portable documents formats, is connected with my previous university and with my previous students also. It's connected with event that we have prepared some system for student conference which were being organized 3 times at my university in Wrocław. And the system was prepared for such a useful tools that we have really great problem for organizers usually. The problem is how to evaluate the compatibility of papers sent for submission for conference, for journal, with such a formatting style prepared by publisher. The one well-known solution for this is IEEE have such a system for compatibility, but Springer not, ACM not, and many others not. They don't have. And why? Why IEEE is not so common in the world at the moment? Because if you use this IEEE, the system, there are many, I think, many weird results sometimes, and you have to cooperate with IEEE themselves. It's not in automatic way. If you prepare your paper strongly due to publisher instruction, usually the system shows you a lot of errors, a lot of mistakes, style mistakes, font mistakes, margin mistakes, a lot of difficulties for the papers. And why? I could show you why this happened. This is the style of IEEE, exactly. So we have to prepare such a paper like this, and this is the main goal for this presentation, to present a method for verification of PDF documents, because PDF documents is our format that we send for the publisher. Usually, we don't send source code. We don't send source style. This is maybe not too good that we don't send really our source file, because we send PDF, and with PDF there are many problems. In this method, we use go twofolds. We go with PDF as an image, and we go with XML as a structure for the document. But the XML and image are generated automatically from the PDF. Because we add the input, we have only one file, PDF. And what we can do, we go 2 ways to parallelize our analysis and to reinforce our result in one result. How? We call it data-driven approach because it's data-driven approach this way. And we see on this picture, on this image, that the same article, the same paper, could be formatted different way, of course. Yeah. There are many ways. The algorithm that we use these two ways. We use this JPEG, JPG images and XML files generated from PDF file. We use two values, two metrics to show the compatibility with the style. So we use tolerance value and we use common section value. Tolerance value determines the tolerance for disparity in positioning the blocks generated from XML and GPG files. Common section value, this parameter determines the common area for blocks derived from the XML and GPG file, indicating the maximum difference in size between them. We use these two metrics because one is not enough. If you see, the one is going about positioning, but the positioning is not enough. We have to know how is covering also, because they can cover, but the position could be different. So we use this combined indicator. The algorithm is going through some steps. The first step is identifying mandatory and unique blocks. In every paper we have such a mandatory like title, outros, abstract, and many chapter sections, following sections. But also there are some non-mandatory, non-obligatory. For example, acknowledgement is not obligatory, but sometimes yes, there is. The subsequent steps consist of the recognition of first level headings. Usually in our scientific papers we have at least first level headings. The next step begins with detecting all potential images. We just recognize blocks of text or blocks of images. So equation, images, tables, we use like images for us, for simplicity. The next round consists of detecting level 2 and more headings, because there are some subsections and so on. Tolerance value determines for us whether a given result is registered as an error or as a warning. Error is disclassified for the paper to be prepared for publication, to be final camera ready file, and warning is only the information that there are some differences, but we can go over this. The result at the first is to recognize the blocks and recognize from the JPEG image and XML file overlap the blocks. So we can see, for example here, that this is one mistake. You see where? Here, this is the block of the image, but unfortunately this label is also separate block for this algorithm. This is one problem, because if you see, this is the label for the image and it is separated, yes, here, it's okay. we just can use it, but this label for the axis is our failure here, our error. And there are many such. For example, next example is we see these blocks are overlap as one block. This is also a problem to recognize the paper, and the references is also, there are many blocks with the references. We should optimize the algorithm to avoid such errors. So for the method, we tested 50 randomly picked papers submitted for the conference, prepared due to the style, due to the publisher style, and we identified level 1, level 2, captions, images, title, abstract, affiliation, keywords, references, synopsis, and what we have obtained. Maybe this is not so valid. This one is important, that we see different problems amending the typeface and font style for keywords block. This is the percent of amending. Missing author and keywords blocks in recognition process, of course, is 81. Missing only keywords blocks is 86. Using Arial font for whole document, it was in the requirement set, 62. More than 12 changes in font style and font size, it was 77. But if we optimize the method somehow, some details, it's not written here, it's not shown, it's not time for that. We just received the following results. The keywords, we have traditional true positive, true negative, false positive, false negative classification of errors. And we use this F-score for this classification. We see that the best F-score is for keywords. So really the keywords from the paper are at 1. So we can use for sure keywords as a main attribute for the paper. And if we see authors, next one, authors, titles, and abstract. Authors and abstract is also a very good indicator, but not so good is affiliation from the only first page. And now you can understand why IEEE, this checker for style, is so not so good for even if we optimize in some way the algorithm. If we use keywords, author, abstract, and only this, the percentage is really high. But if we want to recognize all the elements, it's going down for the next element. This is the best element for recognition. We're going a little down and we see some errors, warnings. We usually, if we compare from human point of view, we can tolerate it. But for computer, of course, not. There is conclusion now. This is example without tolerating images. We just omit images for this recognition. If we omit the images, if we omit images, our results were not so good, because we made more errors, so we cannot emit images in our recognition also. Better if we, for example, recognize also tables, not just images, but also tables. Tables are very important in the papers. Conclusion. The list of errors and warnings which are produced after the recognition allowed indication and correction of the elements which are wrongly formatted. But what is very important, that the errors should be more informative for the users. Not only said that you use wrong font, you use wrong style, you use wrong size. It should be written in the information where is used the wrong font, where is used the wrong style. So it could be even so that it could be more reformat automatically. So this is the idea, that we got the wrong formatted paper and we built the program, the application, to reformat the wrong formatted paper to the right one in automatic way. The next conclusion is that first level headings, title, keywords, author, abstract, affiliation are the most important in this recognition. And the first page is a model for recognizing our headings also. The last conclusion was that if we use only PDF as an image, it's not enough. So if we support our method by XML structure already written, so if we use, for example, source file from the authors, we can really correct the paper in an automatic way. So this is our further aim for this work. That if we just require from author source file, we can make it very good we can make the right presentation, right paper ready to publish. Thank you for your attention. Everything clear, I see.
We all deal with these problems.
Yeah, I know exactly. So that's every time we just if you author, if you reviewer, if you editor, a lot of work is needed to be done and wasted. Yes, so I show you that the problem is really not so difficult to resolve. It could be done, and I wonder that only IEEE has such a checker. It's not so good, of course. It should be improved a lot, but the problem is really, even I can say simply to solve it. And to give such a method that I require for authors is possible. That I work for Elsevier, for example, we require LaTeX files. We require APS files, so for graphics, we require all. So we can make the correct, it is already done, almost already done, that if we require the files, it is done due to style, because we use the style in the paper, yes? So this is one way, but another way is that we just use this PDF file, because it's not everyone use LaTeX. With Word is terrible. You know everything. How it's terrible when you use equation, for example, in Microsoft Word. But we can use PDF at the almost, I think, almost acceptable level at the moment. So every conference, every journal can use such a checker. So it's ready to use it.
Too many guys went to computer science instead of programming.
Maybe, but we have students, so we have a great support for students. We usually not program at myself. Yes, we can support the students. We can be supported. Yeah, we just show that I can not give you one number. We give you a number for each element that we can recognize. So separately. It is why we do that, because some papers there are some restriction, obligatory, non-obligatory elements. Some elements are repeatable or only once in the paper. So we just make such a model for the paper, and we can compare PDF with this model. Yeah. So we can say that this element is more important, is the most important, and we can recognize this element at almost 100%. And some elements are very difficult to recognize, and we can say that we can add some tolerate merging, because for the element we also define such a tolerate merging. For example, we can tolerate the page size in some mergings. Yeah? So we can tolerate as a publisher, because for the PDF generators, there are many generators of PDF, and they do it different ways. So if you generate from Acrobat, or if you generate from Microsoft Word, or if you generate from such a LaTeX framework, you can generate the same file to the different files in PDF. So we have to use this merging, because some elements are floating on the page a little bit. So this is the problem. So we use for each element merging that could be floated, and the other problem is with the fonts for the Adobe PDF files. The font style, font text, font size, this is a problem. Different system. If you use Linux or Macintosh and you generate with different names of fonts, you have to support such tables, substitute tables for fonts, for example, for different systems. But there are many implementation issues, of course. But the main idea is that we can make it. So that was the main idea. Okay. So thank you very much, and we have the last presentation. Thank you, Jason, for sharing. The last presentation is Ongjin Choi.
Ongjin.
Ongjin?
Yes.
Yes, Ongjin Choi. Please introduce at first yourself.